let's go through some definitions. So interquartile range. So these are measures of a spread. So the first one you need to know is range, which is maximum value take away minimum value. But the thing to remember is this is affected by extreme values. So it's not a good measure for spread. Now the interquartile range, which is IQR, is the difference between the upper quartile and the lower quartile. So it considers the middle 50% of the data. Therefore, not affected by outliers. Other thing that you might be asked to work out is interpercentile range, which is the difference between values of two given percentiles. So it might be the difference between the 80th and the 10th, so on. Okay, let's go through the example. You're still using linear interpolation to work it out, so there's no new technique you need to learn to work these out. Okay, the table shows the masses in tons of 120 African bush elephants. Find the estimate for the range. So the range is biggest value, which is 6.5, take away the smallest value, which is 4. So it's nothing to do with the frequency. Remember, the frequency is how many times these numbers come up from each class interval. It's always the highest mass, take away the smallest mass. So range is equal to max take away min, which is 6.5, take away 4.0, which is equal to 2.5. B is interquartile range, so that is equal to Q3 take away Q1. So that means, first of all, I will need to work out Q1. So we know N is equal to 120, because we're told that here. So Q1 will be equal to a quarter of 120, which is equal to 30. So it's the 30th value. So Q1 is the 30th value, so it's 13 plus 23 is 36. 36 plus 31 is 67. And so on, we don't need any more, so we want 30. So it's going to be, we're looking for 30, it's in this class interval. So it's between 4.5 and 5 in this class interval, and it's going from, the frequency goes from 13 to 36. So if this is A, this is B, this is C, and this is D, then A over B is equal to C over D, which implies Q1 minus 4.5 is equal to 5 take away 4.5, which is 0.5. is equal to 30 take away 13, which is 17, over 36 take away 13, which is 23. Which means if I rearrange, Q1 will be equal to 17 over 23 times 0.5 plus 4.5, which gives me a value of 4.869565, which is equal to 4.87. These were measured in tons. It's T, or tons, yeah. So that is, oops, that's not the final answer, so we don't want to highlight it. So 4.87. Okay, now I need to do the same thing with Q3. So it's 3/4 of 120, which is the 90th value. So the 90th value, 67 plus 34 is 9,801. So that means it will fall, because I want the 90th value, it will be falling in this class interval, which means Q3, which is the 90th value, lies between 67 and 101. And and the class intervals are 5.5 and 6. So A over B is equal to C over D. So A over B is equal to C over D, which implies Q3 minus 5.5 over 6 take away 5.5, which is 0.5, is equal to 90 take away 67, which is 23 over 101 take away 67, which is 34, which implies Q3 is equal to 23 over 34 times 0.5 plus 5.5, which means you get 5.838235 blah blah blah, which is 5.84 tons. Now we were trying to find out interquartile range. So interquartile range is Q3 take away Q1, which is 5.84 take away 4.87, which is equal to 0.97 tons. So that's part B done. C says find the 10th to the 90th interpercentile range. That's going to be quite long, so let's do it here. Okay, C. The first thing I need to do is work out P90, which is 90 over 100 times N, which is 120, which works out to be the 108th value. So if I'm just gonna, so I can see the rest of it. So P90 is 108th value. So let me just rub it out because I don't want this. So the 108 will fall in this interval. So it lies between 6 and 6.5 and goes from 101 to 120. So A over B is equal to C over D, which implies P90 take away 6 over 6.5 take away 6, which is 0.5, is equal to 108 take away 101, which is 7, over 120 take away 101, which is 19, which implies P90 is equal to 7 over 19 times 0.5 plus 6, which is equal to 6.18421, which is equal to 6.18 tons. Now I need to work out P10. So P10 is equal to 10 over 100 times 120, which is the 12th value. So P10 is the 12th value, which is going to be in the very first class interval. So it goes from 4 to 4.5, going from 0 to 13. So A over B is equal to C over D, which implies P10 minus 4 over 4.5 take away 4 is 0.5 is equal to 12 over 13, which implies P10 is equal to 12 over 13 times 0.5 plus 4, which is equal to 4.46153 blah blah blah, which is 4.46 tons. So I'm working out the 10th to the 90th interpercentile range. So it's P90 take away P10 is equal to 6.18 take away 4.46, which is equal to 1.72 tons. Okay, next question. The table shows the monthly income for workers in a factory. Calculate the 34th to 66th interpercentile range. Estimate the number of data values that fall within this range. Okay, so the first thing I need to do is work out what 3 plus 24 plus 28 plus 15 is equal to. it gives me 70. So it's 3, 27. 27 plus 28 is equal to 60. 55. And this is 70. Okay, so A is equal to P34 first, which is 34 over 100 times N, which is 70, which I get 23.8 value. So that means P34 is 23.8. So if I look for 23.8, it's in this class interval. So it lies between 1,000 and 1,100, between the frequencies of 3 and 27. So A over B is equal to C over D, which implies P34 minus 1,000 over 1,100 take away 1,000 is equal to 100, is equal to 23.8. Just write that number clearly. 23.8 take away 3, which is 20.8 over 27 take away 3, which is 24, which means P34 is equal to 20.8 over 24 times by 100 plus 1,000, which gives me a value of 1,086.6 recurring, which is equal to 1,086.67. So that's P34. Now I need to work out P66. P66 is equal to 66 over 100 times 70, which is equal to 46.2 value. I should say second, but it doesn't matter. So that means P66 is 46.2. Now 46.2 lies in this interval. So it lies between 1,100 and 1,200. The frequency goes from 27 to 55. So A over B is equal to C over D. A over B is equal to C over D, which implies P66 over 1,100 take away 1,200 take away 1,100 is 100, is equal to 46.2 take away 27, which is equal to 19.2 over 55 take away 27 is 28, which implies P66 is 19.2 over 28 times by 100 plus 1,100, which gives me a value of 1168.571429 blah blah blah, which is 1168.57. So P66 take away P34 is 1,086, no, the other one, 1168.57 minus 1,086.67, which gives me a value of 81.9. Because it's measured in pounds, this is 81 pounds 90. Okay, estimate the number of data values that fall within this range. Now, P34 is the 23.8th value. Oops, undo. So let me highlight what I'm using. So P34 is the 23.8th value and P66 is equal to 46.2 value. So that means B, number of data values, is going to be 46.2 take away 23.8. Now if I do that, I get 22.4, but obviously we can't get that because it's data values, which are whole numbers, which is approximately, obviously if I round it, it's going to be 22. Therefore, 22 data values within this range. The following table shows the mark obtained in tests by a class of children. Mark, so on. So let's just work out, because we might need it. It's 4 plus 7 plus 6 plus 5 plus 3 plus 2, which is 27. A, using linear interpolation, calculate the median, the 87th and the 87th percentile of this. Okay, so A, part 1 is Q2, which is median, is half of 27, which is equal to 13.5th value. So 4, 11, 17, 22, 25, and 27. So that means Q2 is 13.5, which lies in this interval between 40 and 50, between the frequency of 11 and 17. A and B, C and D. A over B is equal to C over D, which implies Q2 minus 40 over 10 is equal to 2.5 over 6, which implies Q2 is equal to 2.5 over 6 times 10 plus 40. Now, if you put that into your calculator, you get 44.16 recurring, which is equal to 44.17. So that's part 1 done. 87th percentile is P87, which is 87 over 100 times 27, which is equal to the 23.49th value. So now I'm doing P87 is the 23.49th value. So if I think about where would that fall, it will fall between 60 and 80. So between, in the class interval 60 and 80, the frequency goes from 22 to 25. So A over B is equal to C over D, which implies P87 take away 60 over 80 take away 60 is 20, is equal to 23.49 take away 22, which is 1.49, over 25 take away 22, which is 3, which implies P87 is equal to 1.49 over 3 times 20 plus 60, which gives us 69.93 recurring, which is equal to 69.93. Calculate the mean of this data. So because it's a grouped frequency table, it's sum of f of m, where m is the midpoint, over sum of f, which is equal to 15 times 4 plus 35 times 7 plus 45 times 6 plus 55 times 5 plus 70 times 3 plus 90 times 2, all over the total frequency we've already worked out, which is 27, which gives me a value of 45.925925 blah blah blah, which is 45.93. So a second class of children took the same test. Their marks were found to have a mean of 52 and a median of 44. Compare the distributions of the marks in the two classes. So the mean of the first one is 45.3, so the mean has increased. So C, mean is higher. The mean is higher in second class, therefore they must have some very high marks. Possible outliers as median, because median is 44 for the second class and median is 44.17, so the median is similar. So if the median is similar but the mean is higher, it must mean they must have some extreme values, very high values. Okay, and the second comparison I can say is obviously the median is similar, therefore we can compare using IQR by ignoring very high marks in second class. Okay, next question. So the noise levels at 30 locations near an outdoor concert venue were measured to the nearest decibel. The data collected is shown in the grouped frequency table. Calculate an estimate for the mean level. So again, it's a grouped frequency data. So x bar is equal to sum of f of m over sum of f of f. Let's do 1 plus 4 plus 6 plus 6 plus 8 plus 4 plus 1, which is equal to 30. So sum of f of m is the middle, so 67 times the frequency plus the middle of the next one, which is 72 times 4 plus 77 times 6 plus 82 times 6 plus 87 times 8 plus 92 times 4 plus 97 times 1, all over the total frequency, which we figured out is 30. So we get 82.3 recurring in the calculator, which is equal to 82.33, and the units are decibels. A noise level above 82 decibels was considered unacceptable. Estimate the number of locations that had unacceptable noise level. So 82 is in the middle of this class interval, so that means only 3 of these. So going for middle, so 82 onwards, so more than 82. So that means we're doing 3 plus 8, because 82 is in the middle of this interval, which means half of 6 is included. So 3 plus 8 plus 4 plus 1. So B will be 3 plus 8 plus 4 plus 1, which is equal to 16. As 82 is in the middle of 82 to 84. Therefore, 3 of them are 82 and above, if we look at it proportionately. Okay, find an estimate for the median. So C is Q2, which is half of N, which is half of 30, which is 15th value. So Q2 is 15. So 1 plus 4 is 5, 5 plus 6 is 11, 11 plus 11 and 17. So that means the class interval that it falls under is this one. Upper bound is 79.5. So lower bound is 79.5. Upper bound is 84.5. 15 is between 11 and 17. So A over B is equal to C over D, which implies Q2 minus 79.5. 84.5 take away 79.5 is 5, is equal to 15 take away 11, which is 4, 17 over 11 is 6, which implies Q2 is equal to 4 over 6 times 5 plus 79.5, which is equal to 82.83 recurring, which is equal to 82.83 decibels. Okay, that's that done. Next question. The age of 300 houses in village are recorded given the following table of results. Use linear interpolation to estimate for these data A, the median. So median is Q2. So if I do first 36 plus 92 plus 74. Oh, it's 300 already, we know, sorry. So we don't need to do that. So it's 300. Q2 is equal to half of 300, which is equal to 150th value. So Q2 is 150. 36 plus 92 is 128 plus 74 equals 202, 241, 255 and 282 there, and 300 right at the end. So Q2 lies between 128 and 202 in the class interval 40 to 60. Okay, so between 40, between 40 and 60. So A over B is equal to C over D, which implies Q2 minus 40 over 60 minus 40 is 20, must be equal to 150 take away 28, which is 22, over 202 take away 128, which is equal to 74, which implies Q2 is equal to 22 over 74 times 20 plus 40, which is equal to 45.9459, which is equal to 45.95 years. B, the limits between which the middle 80% of the ages lie. So middle 80% means I need to work out P90 and P10. So P90 is equal to 90 over 100 times 300, which is equal to 270. 270th value. So again, if I'm looking for where that is, that would be in this one, this class interval. So P90 is the 207th value. It's between 200 and 300, lying between 255 and 282. A over B is equal to C over D. So A over B is equal to C over D, which implies P90 minus 200 over 300 take away 200, which is 100. 270 take away 255 is 15. Over 282 take away 255 is 27. So P90 is equal to 15 over 27 times by 100 plus 200, which is 255.5 recurring, which is equal to 255.56. Now to find P10. So P10 is equal to 10 over 100 times 300, which is equal to the 30th value. Now the 30th value will be in the first interval. So P10 lies between 0 and 20. It's the 30th value lying between 0 and 36. A over B is equal to C over D, which implies P10 minus 0, which is P10, over 20 take away 0 is 20, is equal to 30 over 36. So P10 is equal to 30 over 36 times 20, which is equal to 16.6 recurring, which is equal to 16.67. So if I want to work out P90 take away P10, oh no, we don't. We're finding the limits between which the middle 80% lie. So we're not working out the difference. So the limits are, therefore limits are 16.67 and 255.56, or 17 and 256 if you want to round it up. Okay, C. Explain why an estimate of the mean of this data is calculated to be 86.6. So for part C, X bar is equal to 86.6. And explain why the median and the mean are so different, and hence say which you consider best represents the data. So Q2 is equal to 45.95. Because the mean is higher, it means data must have extremely high values. Data must have extremely high values because it's obviously the median is lower, as median is lower than mean. So there are outliers. These affect mean by increasing it, but have no effect on median. Median is better as most of the values are below the mean. Okay, so I would say median is better because it's not affected by outliers. Okay, last question I'm going to go through. So Sunita and Shirley talked to one another once a week on the telephone. Over many weeks, they recorded to the nearest minute the number of minutes spent in conversation on each occasion. The following table summarizes their results. 2 of the conversations were chosen at random. Find the probability that both of them were longer than 24.5. So A is first work out what the total is. 2 plus 9 plus 20 plus 13 plus 8 plus 3, which gives me a value of 55. Okay, so there's 55 calls in total, or conversations in total. And we have to find the probability that both of them were longer than 24.5. They're longer than 24.5. It means it has to be, there's only 8 plus 3, which is 11 calls that are greater than 24.5. So probability both of them longer than 24.5 will be equal to 11 of them are longer out of 55 times the probability of the next one being longer will be 1 less, which is 10 out of 54. So this is conditional probability because one of them has happened. So we're changing it, which gives you in your calculator 1 out of 27. Okay, next one, part B. The midpoint of each class was represented by x and its corresponding frequency by f, giving sum of f of x is 1060. Calculate estimate for the mean time spent on their conversations. So x bar is equal to sum of f of x over sum of f. Normally sum of f of m over sum of f, but because they've already said x in the midpoint, we can change it to sum of f of x over sum of f, which is equal to 1060 divided by the total frequency, which is 55. We've already worked it out, which is 19.27 recurring in our calculator, which is equal to 19.27 minutes. During the following 25 weeks, they monitored their weekly conversations and found that at the end of the 80 weeks, their overall mean length of conversation was 21 minutes. Find the mean time spent in conversation during these 25 weeks. So what we do know is mean of 80 weeks is equal to 21. So total minutes in 80 weeks will be equal to 80, because that's how many weeks, times by the mean, which is 21. 80 times 21 gives me 1,680. So altogether, the time spent in this conversation was 1,680 minutes. Now we know the sum of the first 55 weeks was 1,060. So if it's 1,680 is in the first, all the 80 weeks, if I take away 1,060, I'm left with what remains for the last 25 weeks. So that would be equal to 620. So that means the mean of last 25 weeks, so this is the total minutes in last 25 weeks, which has worked out. So mean of last 25 weeks is total minutes in last 25 weeks, which is 620, divided by the number of weeks, which is 25, which gives me 24.8 minutes. Comment on these two mean values. So the mean has gone from 19.27 to 24.8. So that means the mean has increased. Therefore, length of conversation has increased during the last 25 weeks compared to first 55 weeks.